Welcome to the deep dive. We're seeing this incredible surge in AI power, and one area that's really heating up is how these systems are acting more like independent agents, especially for building software.
Absolutely. It's a huge leap, really. Beyond just AI giving suggestions, we're now talking about AI that can, well, autonomously tackle complex coding tasks.
And that brings us right to our topic today, OpenAI's Codex. Now, this isn't just their standard model, is it? It's specifically built as a coding powerhouse, an AI agent for software development.
Exactly. Think of it as their most specialized tool for coding. It's powered by something they call Codex One.
Okay, Codex 1. So break that down for us. It's like a souped-up version of their O3 reasoning model, but specifically tuned for software stuff.
That's right. Optimized for the nitty-gritty of software engineering.
And what's the big deal with that optimization? What can it actually do differently?
Well, the fine-tuning is key. OpenAI claims Codex One is much better at producing cleaner code, more readable, and crucially, better at following specific instructions.
Right.
And what's really interesting is this focus on iterative testing. So Codex doesn't just write the code, it tries to test it and refine it.
Huh. So it checks its own work, basically.
In a sense, yeah. Tries to get it right before handing it off.
Okay, so beyond just spitting out code, what kind of actual work can Codex do? Like, give us some concrete examples.
The sources lay out a few things. It's designed to automate a whole range of developer tasks.
Such as?
Imagine needing a new, fairly simple feature. You could describe it, and Codex would try to generate the code.
Okay.
It can also, get its hands dirty fixing bugs, or analyze existing code if you have questions about how it works.
Answering questions about the code? That could be useful.
Definitely. And running tests, refactoring code to make it better, even generating documentation.
Wow, documentation too. That's often a pain point.
Exactly. And the sources emphasize it can potentially handle multiple tasks like these at once.
Multiple tasks simultaneously. That
Yeah.
sounds like it could seriously change the developer's day-to-day.
Yeah.
A huge efficiency boost, right?
Precisely. That potential for parallel work is a game changer. Imagine it adding a UI element while also running tests on a different part of the app.
Okay, that could drastically speed things up.
Big.
So it's doing all this in the cloud, yeah, in a sandbox. Can you explain that a bit more simply?
Sure. Think of it like Codex having its own secure, isolated digital workspace, like a protected virtual computer just for its tasks.
So it can't mess with other stuff.
Exactly. It keeps things contained. And it integrates tightly with GitHub, so you can preload it with your code repository.
Ah, so it has the context it needs right away.
Yeah.
Like seeing the blueprint before building.
Gives it that starting point.
And the turnaround time. Sources mentioned 1 to 30 minutes for simple features. That's pretty fast.
It is. For routine stuff, that kind of speed is incredibly valuable.
The sources also mentioned these agentS.md files. What's the deal with those?
Ah, right. Think of agentS.md files as instruction manuals for Codex, but specific to your project. You can tell it, use this coding style, or structure the code this way, or even write commit messages like this.
So you define the rules of the road for it.
Exactly. And the really neat part is that these rules apply recursively.
Recursively. How does that work?
So you might have a main agents.md for the whole project, but then inside a specific folder, you could have another agents.md with more specific rules just for that part.
And the deeper file takes precedence.
Yep. The more specific rule overrides the general one. It's flexible for managing standards in big, complex projects.
That's clever. Like a company-wide policy, but departments can have their own specific guidelines.
That's a great analogy. High-level consistency, but also local flexibility.
Okay, let's go back to the engine itself. This Codex 1 model, optimized from O3. What specifically makes it so good for coding?
OpenAI says the optimization leads to, well, just better code quality, clearer, more maintainable. Plus, it's much better at sticking to the instructions you give it.
Sticking to instructions and the iterative testing we mentioned.
Right. It's not just generating code and hoping. It actively tries to verify it works and makes adjustments.
How did it learn to code like this? The sources mentioned reinforcement learning.
Yeah, basically, they showed it tons of public code. Then, using reinforcement learning, they rewarded it when it produced code that, worked well, followed good practices, and looked like human-written code, especially in the context of things like pull requests.
So it learned the style of coding, too, not just the rules.
Kind of, yeah. Trying to mimic how humans actually write and collaborate on software.
Okay, this sounds pretty powerful. Who can actually use Codex right now? And what's the cost looking like?
So currently, it's rolling out as a research preview. It's available for ChatGPT Pro, Enterprise, and Team subscribers.
Yeah.
And OpenAI plans to bring it to Plus and Edu users later. They're starting with what they call generous access.
Generous access, meaning free for now, but maybe not forever.
Pretty much. The long-term plan seems to involve rate limits. You'll likely need to buy extra credits if you use it a lot.
Right, heading towards usage-based pricing. We saw some numbers for the smaller Codex Mini latest model used in the CLI tool.
We did. That one's priced at 1.50 cents per million input tokens and 6 per million dollar output tokens, potentially with discounts.
So not free, but gives us a ballpark maybe.
Yeah, it gives some indication for the cost structure, even if that's for the smaller tool.
Now, security. That's always a huge concern with AI that writes and runs code. What safeguards are in place?
Critical question. OpenAI emphasizes that it runs in an air-gapped environment.
Air-gapped.
Yeah.
Meaning completely cut off.
Essentially, yeah. No direct access to the wider internet or external APIs. That massively reduces risks.
Okay, that's a significant boundary.
And they also claim it will reliably refuse requests to build, malicious software, building on the safety work from the O3 model.
But other things it can't do right now. Limitations.
Oh, sure. There are limitations at this stage. For instance, it doesn't currently handle image inputs.
No images, okay.
And there's no real-time back and forth while it's working. You can't really chat with it mid-task to adjust things. That might come later.
Right. It's fascinating how quickly this whole AI coding assistant thing is moving. The articles mentioned Google and Microsoft saying a lot of their own code is now AI written.
It really puts it in perspective, doesn't it? It's not just a niche thing anymore. It's becoming quite mainstream.
And there are competitors popping up too.
Definitely. We're seeing tools like Claude Code, Gemini Code Assist. It shows the whole industry sees the potential here. And OpenAI acquiring Windsurf also signals they're serious about this market.
So what's OpenAI's big picture view, their grand vision for Codex? It sounds like more than just a helper tool.
Their goal seems to be evolving these agents into actual virtual teammates.
Virtual teammates.
Yeah, AI agents that can autonomously handle tasks that currently take human engineers hours, maybe even days. They even mention using Codex internally at OpenAI for refactoring, generating tests, fixing bugs.
Eating their own dog food, so to speak.
Exactly. Shows they believe in its practical value.
And are other companies already using it in interesting ways?
Yeah, the sources mentioned early partners. Cisco's using it for analyzing software errors. Temporal for connecting software components. Superhuman lets product managers make small code changes with it.
Interesting.
And Kodiak, in autonomous driving, uses it to improve test coverage, which is obviously critical for safety.
That makes sense. And the idea of splitting tasks among multiple agents.
Yeah, that points towards a future where you might have teams of AI agents collaborating with human developers.
So the long-term dream is seamless integration, like into issue trackers, CI/CD pipelines.
That seems to be the direction, making it a natural part of the workflow. Plus features like adjusting tasks mid-execution, maybe even collaborative planning with the AI.
That would be a huge shift.
A major step towards true AI co-piloting in software creation, yeah.
Of course, it's not perfect, right? The sources mentioned AI agents still make mistakes. There was that study about debugging issues.
That's a really crucial point. Like any generative AI, it's not infallible. It can make errors. That study showing struggles with debugging highlights that human oversight critical thinking. That's all still essential.
So don't fire all the developers just yet.
Definitely not. It's a powerful tool, but it has limitations. We need a balanced view of understand the potential, but also the current reality.
Okay, so wrapping up this deep dive, it feels like Codex is a really significant step, not just code generation, but automating a much wider range of tasks, acting more like a virtual team member.
Precisely. We've looked at its core functions features, bugs, analysis, tests, docs. We've touched on the Tech Codex one, the O3 optimization, the training.
And the practical side access, pricing hints, the crucial safety measures like the air-gapped environment.
Right. And the broader vision from OpenAI, seeing these tools deeply woven into how software gets built, boosting efficiency, and maybe freeing up humans for different kinds of work.
Indeed. And that leaves us with a really interesting thought for you, the listener, to chew on. With tools like Codex becoming more capable, how does the role of a software engineer change? If AI handles more routine coding, where does human expertise become most valuable?
That's the big question, isn't it? What new possibilities open up? But also, what new challenges arise when AI is an active, sometimes autonomous collaborator in creating code? It's certainly a fascinating future to think about.